Hi guys. So this should be a nice short video. In this video, we're going to look at some of the things, the conditions that enzymes are sensitive to, right? So these are the things that would ruin enzyme function. So enzymes are, as you know, proteins, right? And you should recall that protein structure is very highly dependent upon hydrogen bonding. The primary folding of the protein is just a sequence of amino acids, but that secondary folding, where it gets its main shape, is driven primarily by hydrogen bonding between functional groups. And so the overall shape of the protein is relying on those hydrogen bonds. And you should also recall that hydrogen bonds are very weak things. Individually, any given hydrogen bond is extraordinarily weak. When you have a bunch of them in one place, they can work together well enough to hold things in place, right? Like water as a liquid is held together by hydrogen bonding. Right? So it's enough to keep the water in one place. Right? But any given individual bond is going to be very weak. That's why water is liquid. Right? And so these protein shapes are relying on these weak attractions between R groups. Right? And so one of the things that these hydrogen bonds are very weak to is the addition of heat. Right? So the faster the molecules are moving, the less that attraction of hydrogen bonding is going to stick them together. Right? If they're going fast, those weak bonds can't hold them in place. Right? So the more heat you add in, the faster the molecules are vibrating, the less the hydrogen bonds are doing their job. The other thing that hydrogen bonds are very weak to are changes in pH. Right? Adding an acid or a base to the situation will disrupt those hydrogen bonds very heavily because, as you may know, the story of pHs has to do with free protons floating around, hydrogen pluses that are available in the environment. So acids are molecules that are very willing to give up a proton, right, an H plus. They want to get rid of that H, and they dump it into the environment. Right? So those H pluses floating around are obviously going to engage with the molecules that can do hydrogen bonding. Right? And they're going to disrupt that hydrogen bonding. It's going to block the hydrogen bonding. Bases are the opposite of acids. They're looking to steal up an H plus, right? They want an H plus. They're lacking that H plus. They're willing to receive it. And so they will also engage with molecules that are engaging in hydrogen bonding and also disrupt that hydrogen bonding. Right? So if you add heat or change the pH of the environment around the enzyme, you're going to break those hydrogen bonds and you're going to change the shape of the enzyme. And obviously, if you change the shape of the enzyme, it ain't going to work anymore, right? So when we have a protein and we change its shape to what it's not supposed to be, we break it effectively. That process is called denaturation, right? And so when you denature the protein, it loses its function. Change its shape, change its function. Right? So these enzymes won't work if you change their shape. They won't work if you heat them up too much. They won't work if you put too much acid on them. They won't work if you put too much base on them. Right? And so maintaining homeostasis in a living system is very important for enzymatic function. And in turn, many enzymes are very important for maintaining homeostasis. Right? So it's kind of this constant feedback loop. Right? And so if you start changing the conditions, the internal cellular environment in which these enzymes are operating, you start taking away their ability to function. And so any given enzyme will have an optimal functional range that matches or is suitable for the cellular environment that they typically work in. Right? And so as a human, if my average body temperature is 98.6 degrees and I'm mostly neutral, I'm kind of 7-ish for pH, my enzymes are going to work really well at that 98.6 degree temperature, right? And at a neutral acidity. Right? If I am a sea turtle and I am usually chilling in the ocean and my body temperature is, I don't know, 85 degrees. I don't know if that's a typical sea turtle temperature. Whatever the typical sea turtle temperature is, right, its enzymes are going to work at that level. Organisms that exist at different levels at different times will have different sets of enzymes for those conditions, right? So yeah, enzymes, sensitive to breaking, sensitive to denaturation. If we change the conditions in which they function, they don't function great. They break. That's it. Bye.